So you're gearing up for the CASA navigation exam, right? Yeah, it can feel like you're flying into a thick cloud with no instruments, a total whiteout. But you know what? It really doesn't have to be that way. We're going to break down the core concepts you absolutely need to know. Think of this as your clear-as-day flight plan straight to acing that test.
Okay, so picture this. You're up there, flying, and your GPS just dies. Total blackout. How do you know where you are? How do you know where you're going? I mean, this is the fundamental question of navigation, right? Before all the fancy glass cockpits and tech, pilots had to rely on maps, their compass, and some really clever mental math. And for the CASA exam, you've got to master these principles like your license depends on it, which, let's be honest, it totally does.
All right, here's our flight plan for this session. First up, the briefing, where we'll cover the foundational concepts. Then, a quick cockpit check to understand our instruments. After that, we'll talk navigating en route, specifically the 1 in 60 rule. And finally, the final approach where we'll tie all the key relationships together. Sound good? Let's get into it.
Okay, let's dive into our briefing. You know, every single successful flight starts with solid planning on the ground. For navigation, that means you've got to speak the language of direction and maps before you even think about firing up that engine.
First up, let's talk about true direction. So, what is it? Think of it as our absolute, rock-solid, unchanging reference point. It's the direction to the geographic North Pole, you know, the literal top of the Earth, the axis it spins on. Every single aeronautical chart you'll ever use is drawn relative to true north. This is ground zero, our starting point for absolutely everything.
Okay, but here's where things get a little tricky, and honestly kind of interesting. That compass sitting in your cockpit? Yeah, it doesn't actually point to the true North Pole. No way. It's being pulled by the magnetic North Pole, which is basically this huge, shifting blob of molten iron deep inside the Earth, and it's always on the move. So that angle, the difference between where true north is and where your compass wants to point, well, we call that variation. And this is the money shot, right here. This flow is something you have to burn into your brain for the exam. It goes like this. You start with your true course right off the map. Then you apply the local variation, which, by the way, you also get from the map. And that gives you your magnetic heading. But hold on, we're not done. Your airplane itself, all the metal, the electronics, it creates its own little magnetic field. This causes another error, and we call that one deviation. So you have to correct for that using the little card next to your compass, and that finally gives you the compass heading you actually need to fly. Remember it, true to magnetic to compass. Got it?
So, next question. How in the world do you take a giant round Earth and squash it onto a flat piece of paper? Well, you use something called a projection. Now, for the exam, you really only need to worry about two of them. First, there's the Mercator chart. You'll see this for VTCs, visual terminal charts. On a Mercator, a straight line is what we call a rum line, which means it's a constant heading, super easy to fly. Then you've got the Lambert's chart, which is used for WACs and ERCs. On this one, a straight line is actually a great circle, which is the absolute shortest distance between 2 points on the globe. Knowing which chart does what? That's a classic exam question, so pay attention to this one.
Okay, pre-flight briefing is done. Let's imagine we're strapped into the cockpit now. Your instruments, they're your eyes and ears, your connection to the world outside. But here's the thing, they don't always tell you what you think they're telling you. So let's decode what's really going on with those dials.
Okay, let's start with what is probably the single most misunderstood instrument in the entire cockpit, the altimeter. Let me be crystal clear. Your altimeter does not measure your height. I'm going to say that again. It does not measure height. It's just a really sensitive barometer. All it does is measure the outside air pressure, and then it shows you that pressure reading in the form of an altitude. So why is this so critical? Well, if you get this wrong, you could be looking at your altimeter thinking you've got plenty of room to clear a mountain, when in reality, you're flying straight into it.
So how do we make this thing actually useful for, not flying into things? Simple. We have to give it a reference point. The most common one you'll use is called QNH. When you get the local QNH from air traffic control and dial it into that little window in your altimeter, it will then read your altitude. And what's altitude? It's your height above mean sea level. This is absolutely crucial for making sure you're safely above all the mountains and obstacles that are marked on your chart.
But what if you don't really care about sea level? Let's say you're doing circuits at your local airfield, or maybe flying in an air show. What you really care about is your height above the runway, right? Well, that's where QFE comes in. If you set the QFE, your altimeter will read exactly 0 when you're on the ground at that specific airfield. So as you fly the circuit, it's showing you your height directly above that point.
Just take a look at this comparison here. On the left, with QNH set, the altimeter is showing the plane's altitude above sea level. Now look at the right. Same exact spot in the sky, but with QFE set, it's showing its height above the airfield. See that? Same physical position, but two totally different numbers on the dial, for two totally different purposes. You have got to know the difference between these two.
All right, let's move on to speed. And guess what? It's the same deal as the altimeter. What you see on that airspeed indicator, well, that's not what you actually get. It's just the beginning of the story. It's the raw data, and we need to do some work to turn it into something useful for navigation.
So think of this as the journey of speed. There are 4 crucial steps. It starts with IAS, or indicated airspeed. That's simply what the instrument reads. Then we correct that for any instrument errors to get CAS, or calibrated airspeed. Next, we have to account for air density. Because the air gets thinner the higher you go, right? That gives us TAS, or true airspeed. That's your actual speed slicing through the air. But for navigation, we need one more step. We have to factor in the wind, and that gives us GS, or ground speed. That is the magic number. Ground speed is what tells you how fast you're actually moving over the ground, and it's the number we need for all our flight planning.
Okay, so we're airborne and cruising along. You take a look out the window, glance down at your map, and you get that sinking feeling. Uh-oh, you're not where you're supposed to be. You've drifted off track. First thing, don't panic. This is where a beautiful, almost magical little piece of mental math called the 1 in 60 rule is going to save your day.
And here's the rule itself. It's so simple, but it is so powerful. It states that for every 60 miles you fly along your planned track, 1 mile you are off that track is equal to 1 degree of error. It's just some simple trigonometry, really. All it's saying is that there's a predictable relationship between how far you've flown, how far you've drifted, and the angle of your error.
So let's break this down with a practical example. This diagram is straight out of the exam materials, so it's a good one to know. See that line, FPT? That's your flight planned track. That's the line you drew on your map where you wanted to go. Now see the TMG line? That's your track made good. That's where you actually flew over the ground. That angle between them? That's your track error. And the 1 in 60 rule is our secret weapon for figuring out that angle without needing to pull out a protractor in the middle of a flight.
And this is the magic formula you're going to use again and again. To find your track error in degrees, you just take your distance off track, in nautical miles of course, multiply it by 60, and then divide all of that by the distance you've flown along your track. It's that simple. If you can master this one little calculation, you will always know exactly how to correct your heading and get yourself back on track.
All right, we have covered a ton of ground, so let's start bringing this in for a landing. It's time for our final approach, where we're going to consolidate everything into the absolute, must-know, essential takeaways for that CASA Nav exam.
Look, if you're cramming the night before the exam and can only remember one thing, make it this. For direction, it's always true to magnetic to compass. Don't forget deviation. For altitude, remember your altimeter is just a dumb barometer measuring pressure. QNH and QFE give it meaning. For speed, you have to convert your indicated airspeed all the way to ground speed for flight planning. And finally, for corrections, the 1 in 60 rule is your absolute best friend for getting back on track. Got it? Good.
Okay, so we've talked about all these technical calculations, all this math. And yeah, it's all vital stuff. These are the tools we use to turn a line on a map into a safe flight. But at the end of the day, they're just tools. They serve a much bigger responsibility. So, with all this going on, what's the one thing a pilot can never, ever forget?
This is it. This is the pilot's mantra. And trust me, it's in this exact order for a very, very good reason. First, you aviate. That means fly the airplane. Keep it wings level, under control, flying safely. That is job number 1, always. Only when that's done do you navigate. Figure out where you are and where you're going. And only after you've handled flying and navigating, then and only then do you communicate. Never ever let yourself get so buried in a navigation problem that you forget to fly the airplane.
And there you have it. That's your flight plan for mastering the core concepts of the CASA navigation exam. You know, if you can really get these principles down, you're not just going to pass a test. You're going to be a safer, more confident, and more competent pilot out there. So go on, hit the books, and from all of us here, we wish you the very best of luck.